Hi, I'm Dan with Family White TV, and today I'll be assembling an EggTimer Quark. This is the kit that you put together, and this is the order I will be assembling it in. So, without further ado, let's get this stuff set up here. And the first thing we want to do, once we get all the parts out of the way, is to tape the board down. Now, when you tape it down, you don't want to use electrical tape. You don't want to use Scotch tape because both of those products can generate static electricity, and some of these parts can be ESD sensitive. So what you want is just some paper masking tape, just like that. And the first part that we're going to be putting on here is going to be this processor here, so I'll tape down the ends. And we're just taping it down just to give us a good steady working surface so the board doesn't move around while we're trying to get stuff on. Now, let's talk about soldering tips. This tip here is way too big, so you don't want to use this tip. So I'm going to take it off here. Ow! No, I'm sorry. It's actually cold right now, but we're going to take this off, and I have another tip here that has a much finer point on it, and there's one even finer, but I found that I was having issues with heat transfer, so I'm using this tip here. What is this? A Pace 02095. Anyhow, if you probably don't have this soldering station, this is a temperature controlled nice soldering station at my workplace that I'm allowed to use here. So I'll be using this. And my temperature, I found I had good luck setting it to about 600 degrees last time, so I'm going to set it up for 600 degrees right now. Through-hole parts, I normally like to use 700 degrees, but surface mounts is much smaller, possibly a little bit more sensitive to heat, and so I'm just going to go with a lower temperature of 600 degrees. The first part that we want to put on is this microprocessor here, but actually what I'm going to do real quick, because this is a common instruction throughout this, is I'm just going to go ahead and tin a bunch of these pads here. I'm going to tin just one side of each component pad, and that way you'll see why as we go along here. But here we go, and you just want to put just enough solder on. Come on. Just enough solder to grab the part once you get it on there. So that's for the microprocessor here. We're going to do it for the voltage regulator. This is one of the capacitor pads. Here's a resistor pad. You don't want to use a whole ton of solder. Just enough to get the job done. Especially around the pressure sensor here. All those leads are underneath, so you don't want to run the risk of getting solder up under that, because then it's just not going to work for you. Let's see here. There we go. Now most of the pads, looks like I do have one side of each pad. Nope, looks like I forgot one here. Or did I? Am I just not seeing it? Okay, looks like I did get that one. There is also one hiding under the tape here. I'll get that one later. I mean, it's no big deal. So, first thing we want to do is find our processor, and we will remove it from the bag here. This cares about orientation, So you want to make sure you get it right. Get some tweezers out here. Alright, right now it is not orientated correctly. I mean, if you weren't really paying attention, you might put it on this way, but that would be wrong, because this little notch right here, you can kind of see this little hole on top of the part, that is your pin 1 indicator. And on the silk screen, this is, I mean, the pin 1 side usually would have a notch or something like that, but that is the indicator for pin 1. So let me turn this around. And you want to be really careful. Make sure you get this placed as nice and square as you can. Alright, that looks pretty good there. Now, what we want to do is just to get it so it doesn't move, because this moves around really easily on here. What you want to do is hold it down with a pair of tweezers or something. And I moved it. Okay, I got good pressure on there. Now we're just going to remelt the solder on this one lead here. There it goes. And we'll give it a few seconds. It looks like I might want to touch that up a little bit because it might not have flowed very well, but it flowed enough that the part is pretty much locked down. So once you get that there, you want to make sure your alignment's good. It looks like I might not have very much pad spacing to work with on the top there. So shoot, I'm going to have to try and move this down a little tiny bit here. If you need to move your part around, you want to do it when you just have that one lead soldered right there. There, it looks like I have good space to work with. And you don't want to solder all the leads down, then find out it's misaligned. Just work slowly here. Alright, now we will add solder to the rest of the leads here. Wow, that is like really close to that, but I should still have space to work there. And I want to use as little solder as we can, ideally, because if you use too much, you don't want to short these leads together, because that's just not going to work. So you just got to be nice and careful, work nice and slow, and try not to use a gob of solder. Oh, this is moving around a little bit. Yeah, because that little lead there it's just flexing a little bit. I don't know if I like that. Nope, it doesn't look like it took. I will try with some of these others here. And this can be a little harder than it seems. Oh wait, I'm using the wrong solder, that's why. I'm using the solder from the soldering station, and that's a little bit of a thicker gauge of solder. Let me use the solder that they actually provided me with. Dang, come on. Alright, this is being a little tricky for some reason. Give the chip some time to cool off. Let's go back down here, see if I can get this one to flow the way it should. Here, I think that one went now. Yeah, that looks good. And ideally, to be super safe, you would wait 30 seconds in between leads here. I think that's what they said. All right, but you just want to kind of go to opposite sides. That way you're kind of doing some even heating. You're not heating up one side really ridiculously hot or anything like that. There, and that flowed under there. Okay. And I'll edit out and I'm editing out the pauses here just so the video's not ridiculously long. Alright, so here's a good example of something you really want to watch out for, and reason to have a magnifying glass. Because right here, I messed that joint up. You can see that little hair going out there. So before I solder this one, I'm going to correct this. Because if you bridge it with solder, it could be a little more difficult to clean up than if one of the pads is completely dry. So I'm going to fix this, and then we'll keep going here. Alright, looks like it flowed this time. A little bit more solder than would be ideal, but it's okay. I'm not going for an altitude record or anything like that. But got that fixed. Now I go to this side. This would almost be easier if EggTimer made these pads maybe a little bit longer. I mean, this is probably a standard silk screen pattern used for solder paste. Normally these machines would get a solder paste on them. A pick and place machine would put all these on there. I've actually worked at a fab like that where they had pick and place machines that would put these surface mount components. I mean, it's amazing how fast it works. But here we're just doing it by hand. But if they were to edit this pattern and maybe make these pads a little bit longer, I mean, they'd have to do another board revision. But if these pads were a little longer, it might be a little bit easier to do the hand soldering that we have to do here. Alright, that looks like it flowed really nicely. And that didn't flow. At least I'm pretty sure it didn't. A little too much solder on that one, but it's okay. Too much is not gonna hurt anything. And if you use way too much and get a huge globule on there, then it can be a lot easier to end up shorting a pin. But that's also why you want to have your solder tip a little cooler, because if it's too hot, you're going to boil solder everywhere and it's going to splatter, and that just causes shorts and all sorts of not fun stuff. There we go. And you can kind of see when the solder flows there. Like if it forms into a little ball, it hasn't flowed yet. But you'll see the part actually suck it in there once it does start flowing. Come on. I don't like how long I had to hold that on there. Give it some time to cool off here, and then we'll try it again. And it looks like there might actually be some solder on there, but it's hard to tell. There it goes. Let me try putting it on top of the leg there, see what that does. That actually seemed to work pretty well. That one's being, it might be that little via there is just got a little bit of extra solder on there. There we go. Man, come on. Pin 1 is just not being friendly to me. Have to give it some time to cool off. Shoot. As far as this via, yeah, see that's the ground, so it's going through the ground plane on the back, so it's probably acting as a heat sink. So let me turn my iron up a bit to 650. Yeah, because the part doesn't even feel warm here, it's sucking all the heat away. There we go. Come on. Man, what is going on here? And I'm going to clip off a little bit of solder here just to get a nice clean working edge. Make sure that part's not hot. It's not. Alright, I went up to 700 degrees. This ground pit is really sucking the heat away. Alright, finally got it to flow in there. Now, the next part it says is to mount resistors and capacitors in this order. So, going back to my reference sheet, the order of resistors and capacitors is going to be for the next four, this one, this one, this one, and this one. So the first one is going to be the small capacitor. Now there's two different types of capacitors with this board. Those big ones and these small ones. We're going to be doing the small ones, and the silkscreen on this board is actually pretty good at matching the actual component sizes. That can be a trick in itself to get the tape off of this, but you want to be careful so that you don't flick parts across the room. Ideally, you're going to work on a hard surface. Like underneath your workbench will also be a hard surface. You don't want carpet because you drop one of these in a carpet and have fun. Okay, so our first capacitor here, and this is why I tinned one side of these. That way I can just heat that solder pool up, push it right in, and then it'll be held down for in the second part. I'm going to use a different pair of tweezers here. So just like with the chip, we are going to hold it down. There we go. Hold it down nice and firmly. Get your soldering iron in there. Wait 5 to 10 seconds to make sure that solder is solidified. And there we go. Now you don't want to heat this up too long, because what can happen is if you heat this component up too long, you could melt the solder on the other side, and it might stand up on end, called a tombstone on you, which doesn't mean you're dead. I mean, you can try again, but ideally you want to get it right the first time. So let's see if I can get it right the first time here. There we go. Actually, I'm still up at 700 degrees. Let me go back down to 600. Now, the next one is the 10K resistor. That is going to be marked 103. So you can see on there, that's actually upside down. Oh, I see. They're kind of random. So 103. And the way you read this is the first two numbers are just the regular numbers 10, and then the last number is how many zeros. So 10 with 3 zeros, which is 10,000, which is 10K. And on the other kit I got, they gave you some extra resistors, because these can be real easy to either lose or mess up. So, and the board is marked with the values, so 103 goes right there. Now these resistors are the ones that are very easy to tombstone. Oh great, there's another via there. Alright, hopefully I got that. Hopefully, yeah, it looks like it flowed well. Okay, good. And then there's the 10 microfarad capacitor. That is the larger one I showed you. And don't squeeze these too tightly with your tweezers, because if they slip out, then they will go flying across the room, and have fun with that. Wait a minute, I don't have much pad at all. Let me see if I can gently remelt this and nudge it a little bit. There we go. And that time it looked like it melted to the side of the part before it went down on the pad, so you want to make sure it's melted on both sides, otherwise you get a nice cold solder joint. And the last one is the smaller capacitor, just above the pressure sensor. Be really careful here, because you don't want to get solder underneath that pressure sensor. Looks like the part slipped on me just a little bit there, but that's no huge deal. It's close to this hole here, but that's just a via, and it is connected there, so I'm not going to attempt to move it. Alright, now the instructions say to mount the voltage regulator. That'll be this little 3-lead guy right here. This is probably going to take a little more heat because it's such a, I mean, this is the heat sink of the part. It's on a huge pad here. Actually, I might want to just go ahead and turn my heat up to 700 on this one. There, I saw the solder start to flow there. I'm going to hit that again once I get the legs tacked on. There's one. There's two. Let it cool down for a little bit. Ideally, you want to try to get a lot of surface area of the iron touching the components, both the lead and the pad, just to make sure that everything's hot enough to accept solder. There we go. That's on there good now. Now the next is the 10 microfarad capacitor below the voltage regulator, which is covered up by tape right now. There it is. Go back down to 600 degrees. This is a little further from the via, so well, let's actually do this pad. Dang, this one might be a little difficult to hold down. Here we go. Have much pad to work with on this side, but it looks like I should be able to get it on there just fine. There, it looks like it. Hopefully that's on the board there. Looks like it flowed all the way around. Okay. I'll cover this back up. And now we're going to do the two 4.7K resistors to the left of the pressure sensor here. That'll be the ones marked 4, 7, 2 right there. Now at this point I have some kind of resistors kind of mixed up of the board here, so just make sure to pay attention to the numbers on there. Make sure it actually matches the number on the silk screen. It bears repeating, be very careful working around this guy. They solder that part on for you because the pads are underneath. And so that one's very hard to do, let alone fix by hand. That's why when I tinned it, I tinned the pad closer to it because it's easier to just tin and set it down in there than it is to actually get a soldering iron in there. You want to keep the iron on there just long enough for the solder to flow, but not so long that you tombstone the part. Now there's 3 more 10K resistors marked 103 that are going to go on these pads here. And these resistors and these capacitors here, for that matter, are not polarity sensitive. So the 103 doesn't have to match the 103 on the board unless you're OCD about it. But resistor and these types, now there are capacitors that are polarized, but these types of capacitors, they're not polarized. Great, there's a via there sucking the heat away. Alright, I think I got it. Good. And it didn't tombstone. I thought for sure that was going to tombstone on me. Alright, got those resistors done. Now we're going to do the opto isolator, which is going to be this little white part right here. Alright, where's the pin 1 on this part? And it looks like there is either a notch there or a break in the molding. Let me refer to their website just to verify the orientation of this. I'm pretty sure it's going to go this way, but better be sure. Okay, I was right. That, I mean, real hard to see notch up there. That is pin 1. Also, you can see this little F here is going to go over on the top right corner. It felt like it sunk in there real nice. And like the other one, we'll give this one a little time to cool off. And then we'll go to the other side. And while I do that, just to give it time to cool off, I might as well do the other resistors here. Not sure if that flowed or not. There we go. That one looked like it flowed fairly quickly. That's a little cockeyed. I don't like that. There. Not having much luck with that plastic tool, so let's just go back to this slightly magnetic one. I might have to retouch that. Yeah. Maybe put a little more solder on that pad. Alright, now we'll do the last lead on the opto isolator. There we go. Not sure I like how the other side of that looks, so I'm just going to hit it with a tiny bit more solder here. There we go. Alright, and as you can see, the nice people at EggFinder gave you an extra of each type of resistor just in case you mess it up. Probably early on a lot of people are not having good luck with these, and so they threw in extras in case you lose one or whatever. Only gave you 2 of the big capacitors that you need, so you don't have an extra of that, but you do have an extra little one, unless I'm missing something, which I don't think I am. I don't. Look under the tape. No, there's not anything over there. Okay, so now we go to the through-hole parts. For that, I'm going to raise the temperature up to 700 because these through-hole parts take a little bit more heat. Now there's 2 ways to go. We'll do it when I get to there. First, we'll mount the buzzer. That's this guy right here. This guy is polarity sensitive, so there's a plus there, and that is going to match up with this plus right here, and the minus pin will go up here. And yes, this buzzer is going to be straddling this resistor, so make darn good and sure that that solder connection is good. Alright, what's going on here? The spacing seems to be a little bit off. This is right? That's a battery, that's a VIA. And that is where the buzzer goes. I think they might have changed their parts up, and it looks like the buzzer is no longer spaced correctly. Well, there we go. Just had to bend the lead there a little bit, but the buzzer's on there. And yeah, it's going to be above some parts here. Oh, yep, and on the bottom it says, yep, buzz. Buzz. Okay. Sorry, I should have focused that before I got it on there. There's a little hole there. There's your buzzer. I'm not going to wash this board, so this solder is actually going on nice and clean. Now, the next part is to do the headers. So we're going to cut this header pin into two 3-pin sections and two single sections. And I know the way it looks is, why don't you do, and this is what I thought too, why don't you do 3 2-pin sections and the 1-pins, but it makes sense to do it this way because instead of having 3 separate parts to do here, you just put them in like that and it's still going to work just fine for you. And what I'm actually going to do to make sure these stay lined up is I will install a jumper on here on both sides. Might as well just do all 3. And that way this, you can be assured that this is going to be good and lined up. They recommend that you tape this on here. Feels like it's staying on there pretty well. So I will try and not tape it here. Make sure it's focused on the right spot. Alright, and here we go with the jumpers. Come on, Flo. There you go. What's going on there? There we go. There you go. These two will be in the ground and TX holes, and that's for testing purposes with the USB cable that you may or may not have gotten with this. Actually, with the jumpers on the other side, these will stay in real nice now. I'm going to use a little bit less on these just because there are those pins on the other side of this, so I don't want to accidentally get a big solder blob into that part, that IC. That ground one didn't melt on there as nicely as I'd like. So, well, shoot. There it goes. And now for the 2 transistors. Now, here's something that they didn't include in the instructions. Well, they kind of talked about it, but when it comes to mounting these, there's 2 ways that you can mount these. One is through the top, just like that. However, if you're going to use screw terminals on here, you can mount them through the bottom. Like that, and that way you have room to get your screw terminals on there. However, I suppose if you were doing screw terminals, you could mount them through the bottom. But one thing to pay attention to is polarity. These do have a certain polarity. You can see on here that there is this little flange right here. That has to line up with this here if you're mounting it on the top. So if you're mounting this on the top, it's going to go in just like that. However, if you are bottom mounting this, you don't want to simply turn it over and mount it like that. Now I do see that they do have a silk screen on there. Okay, so they didn't mention that in the instructions, but they also didn't have a picture of the bottom of the board. But you do want to make sure you're following the silk screen, because this silk screen is reversed from that side. See, on this side it's on the top, this side it's on the bottom. And that's to make sure that your polarity stays the same, because if you mounted it this way on the bottom, you have to think your pins are all going to be out of phase, so that this is wrong. Make sure that you get this lined up with that little tiny rectangle there on the silk screen if you're going to mount it on the bottom. But anyhow, I'm just going to mount it right onto the top. And you could tape them down, but I prefer, and I know it's kind of hard to, alright, it looks like a good angle. I'm just going to bend this way, bend this that way, bend this way, and that will hold it in place there while I solder it. There we go. Might as well get the other one in so I can alternate parts and not heat one up more than the other. There it goes. Alright, and there we go. Now I can go ahead and clip these leads off. Those look pretty good. So there's the assembled board. Now I just have to figure out how I want to go ahead and do my battery leads. And I got a little LiPo battery here with, well, yeah, I can pick my phone up now, I suppose. Let's go ahead and do a quick inspection of everything here. Those look good. Those look good. The resistors. Looking at that third one from the top there. Well, let me. Alright, I don't like the way this one here looks. It looks like it didn't really flow up the side of the chip. So I will touch that up. This one, yeah, I'll hit that one again too. Now all the parts are on there. You want to be careful not to touch your soldering iron to anything you've already mounted. Oops, sorry, you didn't see that. I lost track of it with the board not being taped down. There, that looks a lot better right there. Yeah, that looks better now. Oh yeah, it looks much better. Look at these. Of course, with all the parts, you should do this before you get all the other parts on there, but I'm pretty sure that all these were good. Those look good. That looks really nice. Those look pretty good. Alright, I'm happy with the way that turned out. Alright, the way I've decided to do my battery terminals, got these two wires here, and they're going to come up through this hole. And that'll provide a little bit of strain relief. So let's see here, I'll do the white one as battery minus. The blue one is battery plus. And if you're going to use stranded battery wire, you're going to want to tin the wire first, just to make sure that there's not going to be any stray little strands around that can ruin your day. It looks like the insulation pulled back on this one. Let me just push it back down in there, hopefully without burning my finger. There, that looks a little better. I'll go ahead and turn it on. Right, that's the tone that tells me that there's no continuity, because there's nothing here. Alright, I'm gonna solder my drogue wires on here. There we go. And the theory I'm going by here, have these soldered in. I have a nice long piece of wire soldered on here, and so what I'll do is just take some additional wire, solder it onto the end here to my igniter. That way it's soldered all the way down. And the theory is I just have to clip a little bit of this wire off each time, and it should be a really long time, if ever, to when I'll actually have to desolder these and install a new wire on here. Probably what I'd actually do is just install a new wire onto this. So I have a chute release, so I'm tempted to just put a 100 ohm resistor across the main channel and just hardwire it in there. I suppose I could use the main as a backup for the drogue. Of course, the issue there is that it will fire the the main chute I mean, if the drogue doesn't fire, then the rocket will be coming in ballistic, and then the main would fire. But I guess it's a lot better to fire a main while the rocket's ballistic and just zipper the tube, then have it actually come in ballistic. So, you know, I'll probably solder another wire into main. Too bad this hole isn't large enough that I can have the strain relief on that one, but we'll see what I can do with this. Maybe I might just loop it around this wire or something like that. Okay, a couple more solder connections. Where's my solder? There we go. There should be a little bit more strain relief right there. So let's go ahead and hook some resistors up and test it. Alright, we're going to do a test firing of the drogue channel. So to do that, what you do is you put a jumper on the very bottom row there. That's for the drogue, and you turn it on. And as it starts beeping out the prior altitude, right now it's saying 00, but you remove the jumper. Now 15 seconds later, it's going to go into long on-off beeps. 8, 9, 10, 11, 12, 13, 14. Alright. That means it's in test mode, and then to do the test firing, you put the jumper back on, and that'll count down, and 7.4 volts, which is what the battery is actually outputting. And test complete. Now we will turn it off, and I will hook it up to a resistor on the main channel. And we put the jumper on the main side right there, which is the middle one. We'll go ahead and turn it on. We get a long beep and followed by the firing. There we are, 7.45 volts. Alright, so successful test. Looks like it works just the way it's supposed to. We'll have to hook it up to some igniters and test it that way. Beautiful.